Greetings. Welcome. Welcome. So I didn't want to do this stupid, like BS introduction here. And I wanted to just, show some data. But I was talking to myself for like 5 or 10 minutes and the phone wasn't on. I went back and I looked at it and nothing. So it just like starts in the middle there and it makes no sense. So I'll try to reconstruct whatever the heck I was talking about. It was probably nonsense, but whatever the heck I was talking about before. But the main thing was that in the previous video or two videos, we were talking about back EMF, Lenz's law, and what would happen is you would see the back EMF show up as a voltage when you turn the power supply down. It would be 9 volts, but there would still be 3 volts there. And one thing I realized is that, okay, so your actual amp draw, if you're at 9 volts, but there's 3 volts of back EMF, it's 6 volts. And so your actual milliwatt draw, amps times watts, is going to be 6 volts, not 9 volts. And so that kind of changes things a lot. I think that was the main thing I was talking about. I don't know what I was talking about. It was bullshit. I was talking about something there previously, but it was mainly that, you have to factor that in. And then, the interesting, I'm really starting to tease out now, like just, my finger wasn't there, but just like millimeter to millimeter, you see different behaviors with the coil depending on that particular, let's call that the x-axis. No, I guess that would be the y-axis. So let me see if I can parse this together. Okay, this is bad. This is really bad. There's probably like 20 minutes of me talking that was just lost forever. Oh no. So I'll just explain it to you, and then I'll try and graft in the rest of it, and maybe it'll make sense. I don't know if it'll make sense at all. What I was getting at was that, okay, you're spinning the thing, you have your spike, and you can go and look at where the spike is highest and the amp draw is lowest, and looking at what your spike milliwatts in versus your amp draw, your milliwatts in, and compare those and say, okay, I'm getting this percentage out. However, going along from the previous video where we were looking at the spin loss, which is Lenz's law, and you could see when you turn the power supply off that it's at 9 volts, and then you turn it down to 0, but it doesn't go to 0, it goes to 3 volts. And what I realized is that, okay, you're not actually, your input isn't 9 volts. Your input is 9 volts minus 3 volts, 6 volts, times whatever your amp input, your amp draw is. And so you have to modify everything else. And then you have to consider, well, where is the best point in terms of looking at that as well. I mean, I'm not trying to be absurd here, but it's like, let's suppose you had 10 volts as your inductive spike, and in one place you had 9 volts and you were getting 3 volts back, so it was 6 volts that you were using to drive the thing. And in another place, I mean, this is not anything that's happened, there's 9 volts and you're getting 8.9 volts, so you're driving the thing with 0.1 volts. That would be better. So again, that's an extreme example, but I don't know if any of the rest of the video is going to make sense. Okay. But that is what I was getting at. And one of the things I'm doing now is transitioning to, you know, charging batteries and seeing what happens with that. So hopefully if I shut up fairly soon now, this won't be like a 40-minute video, even though it probably won't make a lot of sense because a lot of the good stuff was left out. But, you know, I just told you what the good stuff was. So here we go. My best guess is that if you want to go with battery to battery from the inductive spike, you want it in a place like this, where it's like that. Now there might be a place, you know, a little bit further that way, a little bit further this way, that'll be a little bit better than that. And again, that should only be 40%. Although, you know, if we get out here, we were 40% to start with, and then if I look at what the, so I mean, we're past 40% at higher voltage. But supposedly people do this at 12 volts, and it works, so I don't know. So again, to synopsize, this, I'm guessing, is a good place for battery charging that way. If we put a second coil in here, we're going to see this thing slow way the heck down, and the spike won't be as good, and it'll just be a disaster. If we go out here, though, where you have basically, you know, next to no spin loss, which means next to no lens, I won't say next to no, 1.7 versus 9 volts, and we can maybe do a little bit better than that. You put a second coil in there, you're going to drop the amp draw in half, and it should be spinning at the same speed. So that's the last thing I'll do to wrap up this video. Okay, so here's sort of the game here, or if you like, the two hypotheses. So here's in a spot where, you know, the spike's not real good, whatever. If we turn this down 4.9, I mean, there's a huge amount of back EMF going backwards. So that, to me, means a huge amount of lens. So the first guess, hypothesis, is if we put another coil 180 degrees opposite this, amp draw is going to plummet to more than half. So we're at, oh, what are we at? I don't know. The 35 or something. Yeah, it looks like 35. It will be probably like 15, and the thing's going to slow way the heck down. We're at 11, oh, come on, tell me which it is. 1324, and it'll probably slow down to like 700 or something like that. So it will essentially be, in terms of rotational speed and all that, it'll be garbage. That's my guess. So let's see what it does when we put one in there, and then we're going to put one in another spot, which I think will behave differently. Okay, I didn't nail the numbers exactly right, but I nailed the trends right. So I can't remember what I said. We were at 1300 some RPMs, and we're now 882. I'm going to throw this in a spreadsheet. The single coil, we were at 35 milliamps. I was saying 15. We're at 10. I don't know if you can see it. We're at 10. So even more dramatic than I thought. I can't remember what the spike voltage was. I want to say it was 20 something. It's now 8.3. So I'm going to put that in as well. Here's the kicker though. We were at 4.9 when we shut it down. 6.4, 6.3, 6.4. Oh, I guess I'll call it 6.4. So you know, if we look at it on the spreadsheet, I'm not sure. I wish I'd written down everything. It was close to this one. So like this one was 935, so on and so forth. And so for 315 milliwatts, you were getting 1307 on the RPMs. Here for 90 milliwatts, you're getting 882. I don't know if that's good or bad. I think it's good. I mean, that's like, you know, almost a quarter, and this is more than a half, so I'd have to think that's good. And then even compensating for the fact that you're getting 6.4 back, it's still only 26% efficient versus 30% efficient. So it might be better rotational input, you know, wise, or it might not. But that behaved about like I expected. That's kind of neat. I didn't nail the numbers exactly, but I nailed the trends. So now I'll give you the trends for the next one. And just to sort of reiterate, I mean, the big question is whether that 90 milliwatts versus 315, 1307, is that worse than 90, 882? I think it is. So, I mean, in that case, you should just keep throwing wire at it, and you can change the wire gauge to compensate that, you know, you're not getting any amps through. So here we've moved this thing to the right, maybe a quarter, half an inch probably. And we're doing 16, 13 RPMs. We're drawing more amps now, 50, but that's because that's only 1.7, 1.8 instead of what it was before. So I'm going to jot these numbers down this time, and then we'll compare it with a second one. And there's the spike. What I expect will happen, the hypothesis, is when you have one 180 degrees there in series, this time the amp draw will be approximately 1/2, because there's not going to be a lot more back EMF, but there will be a bit more. So about half of 50, 25, maybe a little bit less, and the rotational speed should be just about the same. So let's see what happens. And I don't know what will happen with that. Okay, this time I was wrong, and it's strange, and I have no idea. So, all right, I like it. Sometimes the light just comes on, but no mistakes, just happy little accidents. 1171, or is that what it is? Yeah, 1173 from 1620. I mean, that's nearly as much of a drop-off as before. Now, here's an interesting one. Remember, before it went from 9 to 1.8, so I would think adding the next coil, it would be like 3.6, 9, 1.8. I got no idea. I mean, how the heck does that happen? All right. The spike is 10.8, and instead of dropping to less than 25, it's only dropped to 35. No good. No good all around. So, all right, let me just throw that in the spreadsheet. Oof. Huh. So this one makes 0 sense. Every single thing seems wrong. One, there doesn't seem to be back EMF showing up here, and there was no more back EMF, even though you added a second coil. Where is it? 1.8, 1.8, not 7.2. 1.8, 1.8. Yet, in that case, the rotor shouldn't have slowed down, yet it slowed down dramatically. It slowed down about as much as the other one. So here you're slowing the rotor way the heck down, and you're not losing that much milliwatt input. Here on that other one, you're slowing the rotor way the heck down, but instead of like 315 in, it's 90 in, and you're still doing 882 RPMs versus 1307. So even though this is a bit faster, that one's better, and the spike stinks here. I have no idea why it did that. I mean, I didn't expect the spike to be good, but I expected this to be approximately 20 or 25, this to be approximately 1600, and this to be approximately 3.6. It's not doing any of that. So again, this is just, it's like a wonderful Rubik's Cube. But the way I would go with it then is in that positioning, there, and eventually you're going to be down to so little milliamps, you're just going to have to either change the wire gauge or throw voltage at it. But it's getting more efficient, both in terms of that, and you're not at a bad place in terms of your spike. All right, I have to stop now. This is enough's enough. But you can see what I'm saying, how there's a lot of complexity here. So what I'm going to be doing going forward is looking at it with batteries, and then I'll show you this. So that's finishing up. See, those are going to be where your pennies are going to go. So it's going to be a penny roll on the outside, and you're going to add mass. And my hypothesis is that while it'll take longer to spin up, it'll actually spin faster, because now there's a place for that pulse to put all of it, instead of it being feather light with just the PLA and the magnets. So as I said, I think I'll wrap this up here. The next video will probably be adding weight to the pulse motor. The video after that, which I'll be doing in the meantime as well, is maybe I'm actually at a successful point here with the battery to battery. I don't know. It'd be a little surprising, at least in terms of what I'm seeing on the spreadsheet, but who knows? I mean, I haven't tried it. So might as well take a look and see whether that works. And I'm still not, away from the pulse motor. The things I want to look at going forward, of course, I've been talking about the bipolar commutation circuit. I rebuilt that, and I fried their Comos AC37 dual channel solid state relay. So I need to order some more of those if I don't have any lying around, and see how things behave with bipolar commutation. I should wind some more coils and see how things do with more wire. What else? I want to look at, on the on the page of Bedini's ideas and motors, there's one for the flux gate, and then that's followed by the I think he calls it the G-force. I don't know where he gets all the names. The G-force motor. The flux gate I've looked at, and it sort of makes sense to me. I've looked previously, if you haven't looked into Thane-Hines bitoroidal transformer. I built one of those, and it works. It works in the sense that if you load one side of the transformer, you get more output out of the other side. You load the other side, you get more output out of the first side. I don't know about over unity or whatnot. The same idea is happening with the flux gate. You're talking about changing where the magnetic flux is going. And after looking at the Thane-Hines stuff, then I looked again at Tom Bearden's motionless electric generator, and that was like the Thane-Hines stuff on steroids. He'd gone through all of the patents and everything, and was looking at the same idea. But the Thane-Hines thing works, the bitoroidal transformer. And in the back of my mind, if I get around to building the flux gate, send it out to a bitoroidal transformer, the output out there. That would be really funny. Okay, so that, and then here's one idea for people just to throw around in the back of their minds. This is one of those where it's like, I just thought of, I've thought of this before, but I thought of it again, And it's so simple, it's like that probably won't work, but I have to look at it, and it can be looked at with the monopole setup. So again, in these past two videos, we've been concerning ourselves with spin loss, which is, it's Lenz's law. And so what about this? What if you took a coil and now you make a bifilar coil, and you hook the two ends up such that the coil is counterwound, such as the patent for the counterwound pancake coil. So now you have, when a magnet spins past, some of the generated electricity is flowing that way, the other is flowing that way. Now, when I pulse a counterwound pancake coil on the desktop, if you just put a rectifier, a bridge rectifier on both ends, you get nothing out because one's going that way, the other's going that way. But what about this? And this is just an idea. Again, this is one of those where I got to look at it, but it's like it's so simple. It's, you kind of think, well, maybe not. But say you have your counterwound pancake coil, counterwound coil, bifilar coil, and you go from one end to the center point. You draw that off to one cap, rectify it, draw it off to one cap. You go from one end, the other end, to the center point, draw that off to another cap. Those two currents are apparently flowing in different directions. Can you draw each of them off and separate them? And if they're both going to a load of equivalent resistance, then there should be no net effect. There should be no Lenz's law. If that worked, and this is a big stretch, but if that worked, then you could gather that off and your rotor wouldn't slow down at all because the net Lenz would be zero. Again, it's one of those where that's simple enough that I think, but I can't think of why it wouldn't work, and so I have to look at it, and it can be looked at with a pulse motor. So maybe those are the next 3 videos or something like that. Anyways, I've gone off for a while again. Thanks. Stay healthy, and talk to you later. Bye. That's done.
What will this do? What will it do?
Okay, talk to you later.